So now we are going to do a change of order in integration, right? Change of order का मतलब होता है कि एक तरीके से x और y का ऑर्डर ऑफ इंटीग्रेशन को बदल देना। अगर आपको पहले x की रिस्पेक्ट में और बाद में y की रिस्पेक्ट में, तो पहले y और बाद में x, इसको चेंजिंग ऑफ ऑर्डर कहते हैं। जैसे 1 2 लिखा होता है तो उसको 2 1 लिख दे तो चेंज ऑफ ऑर्डर हो गया, ठीक है। ऐसे ही काफी हद तक यहाँ पे भी किया जाता है, लेकिन ये ऐसे ही शौक लेने किया जाता है। ये किया जाता है किसी वजह से किया जाता है। जब इंटीग्रेशन जिस ऑर्डर में इंटीग्रेशन रिक्वायर्ड हो या पूछा गया हो, उस ऑर्डर में इंटीग्रेशन करना मुश्किल हो, लेकिन उसके उल्टे ऑर्डर में इंटीग्रेशन करना आसान हो, तब फिर हम चेंज ऑफ ऑर्डर लगाते हैं। जैसे कहा जाए कि कभी जिंदगी में ऐसा हो जाए कि आगे बढ़ना मुश्किल हो जाए लेकिन पीछे लौटना आसान हो, तो ऑफ कोर्स आप पीछे जाने वाले रास्ते को अपना लेते हैं। तो वही हम यहाँ पे करेंगे कि जो गिवन ऑर्डर है, दिया हुआ ऑर्डर है, मान लीजिए ये कोई आपको दिख रहा है इंटीग्रेशन ये वाला, इसमें जो अंदर के लिमिट्स हैं, दीज लिमिट्स आर ऑफ लिमिट्स ऑफ y। अगर आप देख रहे हैं दीज लिमिट्स आर एज अ फंक्शन ऑफ x। अंदरूनी लिमिट जो है वो x का फंक्शन है, स्पेशली नीचे वाली, ऊपर वाली तो कांस्टेंट है। तो गिवन ऑर्डर कुछ ऐसा है कि आपको मजबूर कर रहा है कि पहले y के रिस्पेक्ट में इंटीग्रेशन करिए, क्योंकि y की लिमिट्स अंदरूनी लिमिट्स हैं। लेकिन अफसोस की बात यह है कि ये जो फंक्शन है इसका y के रिस्पेक्ट में इंटीग्रेशन बड़ा मुश्किल है। इनफैक्ट जो डायरेक्ट मेथड्स होते हैं उनसे तो नहीं है, और मेथड्स होते हैं थोड़े नॉन एनालिटिकल टाइप के, उनसे तो हो सकता है, लेकिन डायरेक्ट मेथड जो आप लोगों ने पढ़े हैं उससे इसका इंटीग्रेशन पॉसिबल नहीं है विद रिस्पेक्ट टू y। लेकिन उसके उलट ये है कि अगर काश ऐसा होता कि अंदर की लिमिट्स x की होती, तो इसका लिमिट्स x के रिस्पेक्ट में तो बड़ा आसान था, क्योंकि ये तो कांस्टेंट ही माना जाएगा और x का 1 का इंटीग्रेशन x आ जाएगा, राइट। तो दोनों चीजें आपने देखनी है। पहली चीज ये कि द इंटीग्रेशन ऑफ दिस फंक्शन with respect to the given order of limits is difficult, but if we change the order of the limits, then somehow the integration becomes easy, right? So there should be a hope to evaluate the integral very easily if we change the order of the integration. By changing the order of integration, we just mean that we are changing the sequence of integration in terms of variable x or y, right? So sometimes the integration with respect to y is preferred over x, and sometimes the integration with respect to x is preferred over integration with respect to y. So that is called change of order. ऑर्डर बदल देना। और हाँ, एक चीज ध्यान में रखिएगा कि दिस इज नॉट जस्ट द स्वैपिंग ऑफ ऑर्डर, स्वैपिंग ऑफ एक्स एंड वाई और स्वैपिंग ऑफ लिमिट्स। ऐसा नहीं है कि लिमिट का इंटीग्रेशन का ऑर्डर बदल देने से ये जो लिमिट्स आपको दिख रही हैं ये भी अपनी जगह बदल दें, ऐसा नहीं है। इंटीग्रेशन की जो लिमिट्स होती हैं वो दोबारा से निकाली जाती हैं, और उसको निकालने के लिए ये जो स्टेप्स लिखे हैं ये वही आपको बता रहे हैं कि हाउ टू चेंज द ऑर्डर ऑफ इंटीग्रेशन। ये तो आपको मालूम चल गया कि चेंज ऑफ ऑर्डर लगाना है, क्योंकि आप इंटीग्रेशन कर नहीं पा रहे हैं जिसके रिस्पेक्ट में दिया हुआ है पहले। लेकिन करना कैसे है चेंज ऑफ ऑर्डर, ये इंपॉर्टेंट है। तो उसको करने के लिए 3 स्टेप्स आपको याद रखने हैं। फर्स्ट स्टेप इज ड्रॉ द रीजन आर ऑफ इंटीग्रेशन फ्रॉम द ओरिजिनल लिमिट्स। जो भी दिया गया है इंटीग्रल उसको देखते हुए, उसको हाजिर नाजिर मानते हुए आपने रीजन को ड्रॉ करना है। और रीजन कैसे ड्रॉ करना है ये थोड़ा टिपिकल काम होता है, इतना स्ट्रेट फॉरवर्ड नहीं है ये लेकिन फिर भी इसकी एक टेक्निक है जिससे आप समझ जाएंगे कि हाउ टू ड्रॉ द रीजन ऑफ आर फ्रॉम द गिवन लिमिट्स। हालांकि इससे पहले अभी तक आप कर रहे थे कि रीजन आर पहले ड्रॉ होता था और उसके बाद लिमिट्स निकलती थी, लेकिन अब कुछ उल्टा होने वाला है। अब आज आपको लिमिट्स दी जाएंगी और रीजन आर फिर आपको ड्रॉ करना पड़ेगा, बिल्कुल अपोजिट जो आपने कल तक किया। Now after drawing that region R corresponding to the original limits, we will rotate the strip inside R to 90 degree. So the original limits के according जो भी region बनेगा और जो भी strip बनेगी, of course, right? We will just rotate that strip to 90 degree. So 90 degree rotation of a strip is compulsory, and this is second step number 2 is very important in order to change the order of integration. If you are not rotating a strip, then you will not be able to get the new limits of x and y, right? Now third point is that find new limits of x and y according to the new rotated strip, and then we are going to integrate it very happily, right? तो ये आपका पहले तो ये है कि why we are doing this, हम पे पढ़ी क्यों नहीं चेंज ऑफ ऑर्डर का, शौक के लिए किया जा रहा है ये सब चीजें? नहीं, ये शौक के लिए नहीं हो रहा है। जब आपको इंटीग्रेशन का क्वेश्चन किया जाएगा, डबल इंटीग्रेशन का, 2 बातें हो सकती है, या तो आप उसको आसानी से कर लेंगे जैसे कि लिमिट्स दी हुई हैं, जैसे कि क्वेश्चन में डिमांड हो रहा है कि पहले आप इंटीग्रेशन करिए विद रिस्पेक्ट टू y और फिर जो आंसर आएगा उसको x के रिस्पेक्ट में इंटीग्रेशन करिए। तो या तो आप ये कर पाएंगे या नहीं कर पाएंगे। कर पाए तो अच्छा है, नहीं कर पाएंगे तो उसकी वजह आपको ढूंढनी है कि क्यों नहीं कर पा रहे हैं। तो शायद अगर ये वाली वजह जो मैं अभी बताई आपको, ये वाली वजह कि हो सकता है कि अंदरूनी लिमिट को बाहरी करने से और बाहरी लिमिट को अंदरूनी लिमिट करने से आपका काम बनता हो, तब आप लगाइएगा चेंज ऑफ ऑर्डर, अदरवाइज ये भी लगाने का कोई फायदा नहीं है, राइट। तो एवरीथिंग हैज सम रीजन एक्चुअली, और वो रीजन ढूंढना भी आप ही को है। क्वेश्चन में बिल्कुल नहीं बताया जाएगा कि आप चेंज ऑफ ऑर्डर लगाइए या क्या लगाइए, क्योंकि और भी टेक्निक्स अभी आगे होती हैं, चेंज ऑफ वेरिएबल भी होती है, चेंजिंग इनटू पोलर फॉर्म भी होती है। तो वो भी आपको खुद से ही जाननी है कि क्या लगाना है, राइट। तो आपको खुद ही इंजीनियर बनना है और खुद ही प्रॉब्लम ढूंढनी है और खुद ही उसका सोल्यूशन निकालना है, ठीक है। तो ये मैं आपको बता रहा हूँ कि ये वन ऑफ द प्रॉब्लम मे बी फॉलिंग इनटू दिस कैटेगरी। हो सकता है कि आपकी जो प्रॉब्लम है इंटीग्रेशन न कर पाने की, हो सकता है वो एक वजह इस वजह से मैप कर जाए, और हो सकता है कि चेंज ऑफ ऑर्डर लगाने से आपका क्वेश्चन हो जाए, राइट। एनी प्रॉब्लम इन दिस? Any problem, then please ask, because this is just the beginning of this. Okay, fine. Now we are going to complete this question, because as I told earlier that this question cannot be evaluated just because the interior limits are of limits of y, and nobody can integrate this with respect to y first, but everybody can integrate this with respect to x first. So that's why there's a hope that this integral can be evaluated by applying the change of order. And now I have written the steps how to change the order, and now I'm actually following those steps, right. So what I will be doing, I will be just picking up these limits of y and x, and I will be drawing region R, and I will be drawing a strip inside that. Then I will be going to rotate that, and then I will be going to find the new limits in x and y, and then I will integrate it. Okay. So I'm using these three steps on this integral. Okay, right. Okay, so applying this to the given integral, which was considered to be unsolvable until you didn't know this technique of change of order, right. This is the integral. You can see that the inner limits are of y limits, and they are enforcing you to perform the integral with respect to y. But since nobody can integrate this with respect to y, so there is possibly a hope that this function can be integrated with respect to x, which looks quite easy, because this is just a constant when we are going to integrate with respect to x, right. So of course the integration can be performed if and only if we change the order of these limits, right. Means the outer limits should be of y and the inner limits should be of x. But in order to achieve that goal, we have to draw pictures first, right. So I'm going to draw axis first. This is my y-axis, right, and this is x-axis. And now it's very important, please pick up the numbers from the inner limits. You see that these are y is equal to x by 2. If I write it more precisely, that is actually y is equal to x by 2 and x is equal to 0, right. So y is equal to x by 2. You have to draw this line, y is equal to x by 2. Y is equal to x by 2 is a line going through the origin with a slope of 1 by 2, right. So it will be something like this, y is equal to x by 2, something like this. Okay, so y is equal to x by 2, right. And this is actually these inner limits are actually the guiding curves of the strip. It means that the strip is standing on this curve, right. The base of the strip is lying on this curve, and the head of the strip is always below this curve, right. So these inner limits are actually telling you that these are actually the curves which are below the strip and just above the strip, right. You can say that guiding curves. Okay, this is y is equal to x by 2, and the strip will be resting on this this line like this, right. So I will draw, not let me make a straight line like this. Okay, so this is a strip. You can see that I have just mentioned that the base of the strip, this is the base of the strip, is lying on the curve y is equal to x pi. This line is y is equal to x pi 2, right? Now we will decide about the head of the strip. Below which curve the head of the strip is lying. See, the head of the strip is lying below y equal to 1. So let me draw y equal to 1. This top of the strip is lying below the line y is equal to 1. Of course, this line is y is equal to 1. So if this line is y equal to 1, then this the coordinate of this point will be something like 1 comma something, because y is equal to 1. So that's why you always know that y is equal to 1 here. So there should be some x. So let us put this y equal to 1 here. Then x will be how much? X will be equal to 2. It is just the intersection of these two lines, right? Okay. Now see, I have used these inner limits, but still the outer limits are not used now. This is x equal to 0 to not infinity, actually, sorry, it was 0 to 2, actually, sorry, 0 to 2. Okay, so this is going to be a finite bounded region, that's why. Okay, x is equal to 0 to 2. Now these outer limits are actually showing that the motion of the strip should start from here, and it should be terminated at x is equal to 2, right? So the outer limits actually tells you about the motion of the strip, right? So I will draw an arrow to show the motion of this strip, right? So this is the motion of the strip. Motion of the strip is always away from the origin, you all know that, right? So it's like this. There's a motion of the strip, right? And when the strip will start its motion, then it will be touching this y-axis, of course, right? You know that this strip will be standing at the leftmost position, this position, and at this position your x is equal to 0. And finally, when it is going through its journey and it will reach this end point, then what is the value of x at this point? X is equal to 2. So this picture completely describes the motion, and this picture uses everything from this integral. All the four limits have been used here. You can see that the motion of the strip is started at x is equal to 0. You assume that the strip is starting from here, right? And the strip will go like this, and at this point the height of the strip will be completely diminished, and of course at that point x is equal to 2, right? So these outer limits are also used now, right? And out in this, right? So let me shade this region, right? So this is the region R we are talking about, we are interested in, right? Okay, so this is the region R. Let me write capital R here. Okay. Now, since this is just the completion of step number 1, now what I'm going to do, I'm going to rotate this strip through 90-degree angle, right? So I will just copy this picture once again, and we'll just rotate what this strip. What I'm going to do now, I'm going to actually remove this strip because it has been made with vertical strip. I will be going to draw a horizontal strip rather, right? Because I'm going to rotate the strip to the angle of 90 degree, right? So when I do this, these arrows actually, no, they don't have any meaning actually, right? Okay, so let us make a new strip, and that new strip will be a horizontal strip like this. We have rotated the strip through 90-degree angle inside the region R. Please note that your rotated strip should lie in the region R, right? It's not like that you are going to take out your strip from the region R. No, you can't do that. Okay. So this is your region R. Still the region is same, but now please pay attention. Please tell me, Sonu Singh, please appear. Yeah. Tell me where the base of the strip is lying. This is the base of the strip. You always know that base is always towards the origin. This is not the base. This is the head of the strip. This is the base of the strip, and on which curve it is lying? Please tell me the equation of the curve. Okay, good. X is equal to 0, and the head of the strip is this, and it is lying below the curve. What? X is equal to 2y. Very good. X is equal to 2y, because though it was y is equal to x by 2, but just give the nomenclature in such a way that x is equal to 2y, because now they are giving the limits of x. Now, okay. Now tell me the motion of the strip. The motion of the strip will be in the upward, like this direction, right? Yes. Oh, sorry. This direction. Upward direction. Okay, right. And originally the strip will be here at this point. You know, you're seeing this point, right? And at this point, what will the value of y?
So 0, 0, 0.
Y is equal to 0. So at this point, y is equal to 0. Of course, I will write here 0 comma 0. There is no harm to write the coordinate. And when you reach at this finally the strip will reach at this position, and at this position y will be equal to 1. So the limits of y are 0 to 1, right? So this is picture number A, figure A, and this picture came out from step number 1, and this is your figure B, and this picture came out from step number 2 when you rotated the strip. And this gives you now the third step, find the new limits of x and y. Now who will be telling me the new limits of x and y? Please come. Limits of first you write the limits, inner limits, and inner limits are given by the base of the strip and the head of the strip, right?
Sir, x is
So
equal
inner
to 0.
limits, x is equal to 0,
2x is
to
equal to 2y.
2y, and now the limits of x which are given by the limits of y which are given by the motion of the strip, they are always
0 to 1.
constant. So 0 to 1. So please ask if you are finding any difficulty in finding the limits, because this is the extremely important part of finding a double integral. Finding accurate limits is very important, right? So the new integral will be something like this, right? We cannot change the function is always the same, but since the constant limits are limits of y, so they will be positioned outside, right? The outer limits are always constant, and the inner limits may be variable limits, and you can see that the upper limit is a variable to y. Now let's see that since we are going to integrate with respect to x first, so I'm writing here dx first, then I will write a dy first, and this is just the opposite of what was given originally, right? Now I'm writing dx dy. Okay, now can we evaluate this thing? You focus on this part of the integral and just integrate it with the respect to x, right? I hope you can do that. Integrating this with respect to x is very easy, because this whole function will be treated as a constant, right? And the integration will be x, because the integration of 1 is x, and now the limits of x are 0 to y, and then I will write dy, and then you will plug in the upper limit minus lower limit here in place of x. That gives you a 2y times e to the power y square dy, and now you are left with the limits of y 0 to 1, and this is very familiar integral. You must have solved this integral in +2. How will we solve this integral? We have to, yeah.
So y square is equal to
t, good, and then you differentiate it, then you get 2y dy is equal to dt, and that gives you I is equal to, but please note that whenever you do a substitution like this, you have to change your limits. So just use the inner limit, lower limit, that's y is equal to 0. If you put y is equal to 0 here, then t will be equal to 0, because the square of 0 is 0. And when you put y is equal to 1 here, then the square of 1 is 1. So luckily the limits are same. But now the new limits are of t. So now the e to the power t dt, yes, and now I'm going to integrate it, e to the power t, and then the limits, and e to the power 1 minus e to the power 0, and that gives you e minus 1 is the final answer, right? Now you can see that you are able to evaluate the integral after you change the order of the integration. Earlier, solving this integral is not easy, because nobody can integrate it with respect to y first using those usual methods of integration. I'm not saying that this is impossible to integrate with respect to y, but the usual methods which you have studied in +2 course, you can't evaluate it actually, right? Any problem regarding the application of change of order, why we are doing this? The question is important, why we are doing this? Are we doing it just for fun? No, we are doing it for a purpose actually. कुछ वजह है इसको करने की, क्योंकि इसके बिना हमारा गुजारा नहीं चलने वाला है। और ये भी मैं ये नहीं कह रहा हूँ कि हमेशा इसके साथ ही गुजारा चलेगा, कभी कभी ये भी फेल होगा, ये भी मैं आपको बता देता हूँ। ये सिर्फ इसलिए काम कर रहा है क्योंकि आउटर जो लिमिट्स हैं, या यूं कहिए कि एक वेरिएबल की रिस्पेक्ट में कम से कम इंटीग्रेशन आसान है। जब तक एक वेरिएबल x या y किसी एक के रिस्पेक्ट में इंटीग्रेशन आसान होगा, तब तक ये तरीका आपकी मदद कर सकता है। अदरवाइज कभी कभी ऐसा होता है कि ना x की रिस्पेक्ट में आप इंटीग्रेशन कर पाते हैं और ना y की रिस्पेक्ट में, तो फिर वहां पे वहां पे तो फिर ये काम बिल्कुल भी नहीं करेगा, वहां पे कुछ और टेक्निक लगानी पड़ेगी, राइट। ओके, सो वी आर प्रोसीडिंग फॉर पार्ट नंबर ए, एंड सिंस आई सेड दैट प्लीज चेक फर्स्ट, आप चेक भी कर लीजिएगा कि ये बिना वजह मत लगाइए चेंज ऑफ ऑर्डर, क्या पता आप क्योंकि अंदर की लिमिट्स ये y की लिमिट्स हैं, क्या आप इसका y के रिस्पेक्ट में इंटीग्रेशन कर सकते हैं यूजिंग यूजुअल मेथड्स जो आपने पहले पढ़े हैं। इंटीग्रेशन ऑफ दिस विद रिस्पेक्ट टू y इज नॉट इजी, but if you integrate it with respect to x, that is super easy because it is not involving x anywhere actually. So integration with respect to x is very easy, right? So that's why we are performing changing of order. कोई वजह नहीं है इसको फिजूल में लगाने की, ठीक है। तो चलिए ये बात मैं सिर्फ लिख रहा हूं, या मैं ये कहिए कि ये बात सभी के लिए मैं लिख देता हूं कि हमेशा तीनों ही क्वेश्चंस में एक ही चीज हो रही है कि ये सभी के लिए है। ये क्वेश्चन समझिए या ये नोट समझिए, ये मैं बार बार नहीं लिखूंगा, सिर्फ बता रहा हूं बस एक बार नोट। इंटीग्रेशन विद रिस्पेक्ट टू y, आप देख लीजिए तीनों में आपको तीनों क्वेश्चन जो ऐसे डिजाइन किए गए हैं कि अंदरूनी लिमिट्स y की हैं तीनों में, राइट, और वो आपको मजबूर कर रहे हैं कि y के रिस्पेक्ट में पहले इंटीग्रेशन कीजिए, राइट, और जिसकी वजह से आप क्वेश्चन कर नहीं पा रहे हैं विद रिस्पेक्ट टू y फर्स्ट इज नॉट इजी, इज डिफिकल्ट। लेकिन इसके साथ साथ आप ये भी चेक कर पा रहे हैं कि अगर x के रिस्पेक्ट में इंटीग्रेशन किया जाए तो वो सुपर इजी है, बट integration with respect to x first is easy, so that's why you are going to apply the change of order। अब हम क्वेश्चन में चलते हैं, सॉल्यूशन में चलते हैं, पार्ट नंबर ए, राइट। पिक्चर हमको बनानी पड़ेगी बहुत सावधानी से। सबसे पहले तो आपको बनानी चाहिए एक्स एक्सिस और वाई एक्सिस, क्योंकि उसके बिना तो क्वेश्चन शुरू ही नहीं करना चाहिए आपको। ये आपकी वाई एक्सिस हो गई एंड दिस इज योर एक्स एक्सिस, राइट। नाउ पिक अप द lower limit, the innermost limit, this is y is equal to x. If you write it precisely, this is y is equal to x, so just draw y is equal to x. So that is an oblique line making an angle of 45 degree. I'm not going to show that, right? This is the line y is equal to x, right? So you have just utilized the lower limit, and it tells you that your strip will be resting on this curve throughout its motion. The base of the curve will be resting on this line y is equal to x. You can see that, right? Now we'll talk about the top of the strip, the head of the strip. The head of the strip is lying below y is equal to infinity. What does it mean? It means that y is equal to infinity is like a sky. जैसे आसमान होता है वैसे ये y equal to infinity, इतनी ऊंची छत की छत आपको नजर ही ना है, y equal to infinity। इसका मतलब जो है जो स्ट्रिप है दिस इज ऑफ इनफाइनाइट लेंथ, ये बहुत लंबी स्ट्रिप है। इनफैक्ट मुझे इसको रोकना नहीं चाहिए, मुझे कुछ ऐसे बनानी चाहिए थी, कुछ ऐसे इस अंदाज में कुछ। ये इनफाइनाइट लेंथ की स्ट्रिप है, ये बहुत ऊपर तक जा रही है, राइट। तो मैं इसका टॉप नहीं बना रहा हूँ, ऊपर वाला कर्व मैं बना भी नहीं सकता, मुझे वो ड्रॉ करना ही नहीं है क्योंकि अपर इसका y इक्वल टू इन्फिनिटी है। बट ऑफ कोर्स आई कैन यूटिलाइज दिस आउटर लिमिट्स। द स्ट्रिप is starting from this, what is this is x is equal to 0, x is equal to the 0 is this thing, this is x is equal to 0, right? क्योंकि जब स्ट्रिप का मोशन स्टार्ट होगा वो ठीक यहाँ पे होगी, उस वक्त स्ट्रिप कॉर्नर में होगी, राइट, और उस पॉइंट पे x is equal to 0 होगा, राइट। and the motion of the strip will be terminated at x is equal to infinity। टर्मिनेटेड तो कहना नहीं चाहिए क्योंकि x इंफिनिटी पे जाके कोई रुक ही नहीं पाया, और जहां रुक गया वहां इंफिनिटी है ही नहीं, राइट। तो ये कहना चाहिए कि द मोशन ऑफ द स्ट्रिप इज गोइंग टूवर्ड्स इंफिनिटी, यानी कि ये जो मोशन है ये एक अनलिमिटेड मोशन है जो कभी भी नहीं रुकेगा। तो मैं इसको इस तरीके से शो करूंगा, कुछ ऐसे एरो से, लाइक दिस, नॉट लाइक दिस, straight line like this, right? You can see that the motion of the strip is from left to right, and that is extending towards infinity, right? Are you able to visualize this picture, because that is very important. This picture, this region, I will ask a question to Aman Tomar. Is he here?
Yes sir.
Aman Tomar, is it a bounded region or unbounded region?
Sir, unbounded region है।
अनबाउंड। और ये पहली दफा हुआ है कि हमने कोई पिक्चर बनाई और रीजन अनबाउंडेड है। इससे पहले जितने भी हमने क्वेश्चन किए हैं सारे बाउंडेड पिक्चर्स थे, यस और नो?
यस सर।
हाँ, तो ये पहली दफा हुआ है कि बाउंडेड है। और ये जो लाइन जो मैंने बनाई है y इक्वल टू एक्स, ये मत सोचिएगा ये रुक गई, ये कहाँ तक जाएगी ये भी?
इंफिनिटी तक।
तो मैं इसको एक्सटेंड करना मुझे चाहिए, तो वही मैं करने की कोशिश भी कर रहा हूँ। मैं इसको इन्फिनिटी तक एक्सटेंड कर रहा हूँ कुछ ऐसे करके, सॉरी। कुछ ऐसा, कोई प्रॉब्लम यहाँ तक किसी को इस पिक्चर में? कोई प्रॉब्लम, राइट? और क्योंकि ये जो स्ट्रिप आपको दिख रही है ये वर्टिकल है और इसी का दोबारा से आपको पिक्चर बनानी पड़ेगी। ये जो हेड है स्ट्रिप का, ये जो हेड है ये बना नहीं सकता कोई। ये जो हेड है, ये हेड लाई कर रहा है, हेड जाएगा, ये यूं कहिए कि हेड होगा टुवर्ड्स y इक्वल टू इंफिनिटी। हाँ, हालांकि y इक्वल टू लिखना गलत है, पर मैं आपको एक इंट्यूटिव आइडिया दे रहा हूँ कि द हेड ऑफ द स्ट्रिप इज लाइंग बिलो द curve which is at infinite height above the x-axis, y equal to infinity. Though you can't write y equal to infinity, y tends to infinity is makes sense, equal to infinity कभी नहीं लिखा जाता है, लेकिन मैं फिर भी लिख रहा हूँ, ठीक है? चलिए, इस पिक्चर को दोबारा से आपको रेप्लिकेट करना होगा, क्योंकि पिक्चर तो दोबारा यही बनेगी पूरी की पूरी। बस फर्क सिर्फ इतना होगा कि आपको स्ट्रिप जो है वो आपको रोटेट करनी पड़ेगी रीजन के अंदर, राइट? मैं दोबारा से ये पिक्चर यूज कर रहा हूँ, ये हमने यूज कर ली पिक्चर। बस स्ट्रिप को हम रोटेट कर देते हैं और इस डायरेक्शन को भी अब हमें चेंज करना होगा, राइट? नाउ द इम्पोर्टेंट पॉइंट इज दैट नाउ आई एम गोइंग टू रोटेट दिस स्ट्रिप एंड सरप्राइजिंगली नाउ द स्ट्रिप, the head and base of the strip will be resting between the finite boundaries, which was not the case in the original picture. पहली वाली पिक्चर में आप देख सकते हैं कि जो स्ट्रिप का हेड है वो आसमान तक जा रहा है, बिल्कुल इनफाइनाइट की तरफ जा रहा है, राइट? लेकिन अब जो है हेड और बेस दोनों ही फाइनाइट बाउंड्रीज के बीच में बंधे हुए हैं। हालांकि मोशन तो अभी भी इनफाइनाइट की तरफ है, लेकिन फिर भी कुछ तो चेंज आया है पिक्चर में, राइट? मैं लिखूंगा इनकी लिमिट्स। See the base of the strip. The base of the strip is lying above what? The base of the strip is touching x is equal to 0. The head of the strip is always below x is equal to y, but the motion is again unbounded, right? Motion इस बार ऊपर की तरफ होगा कुछ ऐसा, right? But वो unbounded ही हो, बदलाव नहीं आएगा उसमें, right? एंड जब स्ट्रिप जब स्टार्ट करेगी अपना मोशन तो इट विल बी एट द पोजीशन x इज इक्वल टू 0, राइट? और स्ट्रिप का जो मोशन होगा वो एक एंडलेस मोशन होगा, कभी स्ट्रिप रुकने नहीं वाली है। तो आप कह सकते हैं कि स्ट्रिप का जो मोशन है दैट इज फ्रॉम x इक्वल टू 0 टू x इक्वल टू इंफिनिटी। एम आई राइट? एनी प्रॉब्लम इन दिस? Please stop me if you are facing any problem. And these are just the two pictures, which this is just due to the original integral, right? And the second picture is due to the rotation of the strip, which is now helping you to get the new limits of x and y. You know, who will be telling me the limits? Habib Sheikh. So limits, the innermost limits are given by the base and the head of the strip, that is from x is equal to 0 to y, and the outermost limits are given by the motion of the strip. You can see that the motion will be started when the strip will be here, right? And at this point x is equal to 0, right? So x is equal to 0 to infinity. Of course the strip is not going to stop anywhere. स्ट्रिप रुकने ही नहीं वाली है, चलती चली जाएगी। रीजन बहुत बड़ा है, इनफाइनाइट, right? So now comes the evaluation part, right? I will always keep the constant limits which are given by the motion of the strip outside, right? And then the innermost limits are due to the base and the head of the strip, and the function will be same. Function is e to the power minus y divided by y, and then you write a dx first and then dy second, because the inner limits are of x. Now you are going to integrate this with respect to x first, and that is super easy. So e to the power minus y will be treated as constant, and integration of this thing with respect to x will be x, and then we'll plug the limits 0 to y and then dy, and you can see that when you plug the limits, and then you will get y minus 0, right? And that cancels this y with this y, right? So dy, and integration of e to the power minus y is this minus will be appearing outside, 0 to infinity, and then you will plug limits e to the power minus infinity, right? Though this and in fact this is not preferred in precise mathematical writing. You can't put infinity. Infinity is not a number. Just the mistake I have committed here, but I did it deliberately actually, and I will correct it. Y tends to infinity, right? Y tends to infinity, right? So just do not write e to the power minus infinity. You should write limit y tends to infinity e to the power minus y. This is the correct way to write actually, right? And then e to the power minus 0, okay? And then you know that this will be e to the power minus infinity will be 0, right? And answer will be a plus 1, because minus minus plus 1, e to the power 0 is 1, right? Any problem? Any problem, then please ask. Okay. So this was part number A, and now I will proceed to part C directly, or should I go to part B also? Okay, so let us do part B too. Part B. Okay, so here I is equal to integral. The outer limits are 0 to pi, and the inner limits are x to pi, and then sine y upon y dy dx, right? Of course, these are limits of y, these are limits of x, right? So okay, so I think that yeah, the inner limits are limits of y, so we can say that the base of the curve is resting on the line y is equal to x. You can see that this is y is equal to x for this one, right? And now y is equal to pi. Y is equal to pi will be a line like this. Y is equal to pi, right? I will just erase it, and yes, okay. This is y equal to pi, right? And of course, this point, when you solve this and this simultaneously, you will be getting this point will be a pi comma pi, right? Okay, so the strip will be vertical, of course, and the motion of the strip is actually from left to right, right? And see that the strip is starting from x is equal to 0 and ending at x is equal to pi. You can see that this left boundary is x is equal to 0, because originally the strip will be here, x is equal to 0, and finally the strip will be here at this point, and at that point x is equal to pi. This is the original picture with respect to the original integral and the original limits. This is the region R, right? Now what we are going to do now, you are going to just rotate this strip, nothing else, right? So I will just copy this picture and will paste it here. And that gives you the limits of x. You can see that the base of the strip is resting on x is equal to 0, and the head of the strip is resting below x is equal to y. So we'll prefer writing x is equal to y rather than y equal to x. And you see the motion of the strip will be started from y equal to 0 and it will end at y equal to pi. And in order to show the direction of the motion, I will make an arrow upward like this, right? Okay, so as per the new limits, we can see that the integral will be I'm not writing limits, okay? I will just use them in my integral. Okay. So delete here the new integral as per the new picture, figure number B, and this was your original figure number A. Now you are referring figure number B. You can tell me the outer limits. Outer limits are always given by the motion, and that is from y equal to 0 to pi, and the inner limits are x is equal to 0 to y, and the integrand will be of course same, sin y upon y, and dx will be written first, then dy, and not just matter of the fact of the integration only. You will just integrate it with respect to x, and that gives you x, and then you put y, then y will be cancelled with y, and that gives you 0 to pi sine y dy. I have just skipped one step. You know how you will evaluate this with respect to x in integrated, right? Y value will be cancelled, and then sorry, this will be dy. An integration of sine y will be minus cos y, and I think the answer will be 2. Yeah, 2. Finally, the answer will be 2, right? Now, part number C, and that is I is equal to integral 0 to infinity, and the inner limits are 0 to x times e to the power minus x square by y dy dx. Of course, you can see that the inner limits are limits of y, and the outer limits are limits of x, right? So this integral is forcing you to perform the integration with respect to y, which is not easy. You can see that you can't integrate it with respect to y. It is not e to the power minus y, it is e to the power something like e to the power minus 1 upon y. You can't integrate it with respect to y, right? Okay, so now what we are going to do, we are going to use the change of order, and to do that I have to draw the region of integration first, right? So this is my y-axis and this is the x-axis, and now you draw these cell minus 2 of what? Last answer, sorry, sine minus 2, sine y minus cos y. So minus is taken outside. Minus is integration of sine y is minus cos y actually. I think yeah, plus 2, it should be plus 2. Cos pi is minus 1 minus 1. The answer will be plus 2. Check your calculation once again. Yeah. Okay, so this is y is equal to 0. Y is equal to 0 is nothing but it's just your x-axis, right? It means that your strip will be resting on the curve y is equal to 0 throughout its journey from left to right, right? So something like this. And now see the head of the strip that is lying below y is equal to x. So y is equal to x is a line, oblique line like this. Okay, this is y is equal to x. I have just actually not taken the angle exactly at 45 degree. We are just making these pictures to give you an intuition. These are not exact diagrams, right? So you can't say that this angle is exactly 45 degree. I'm just making rough pictures. ये कोई आपको actual diagram नहीं है, ये एक rough pictures है. This is a strip. You can see that the head of the strip is resting below y is equal to x. This is just due to the inner limits, right? And now x is equal to 0 to x is equal to infinity. Now tell me, the motion of the strip is from, of course, left to right this way, right? We'll draw a straight line like this way. Okay, and it will start from, of course, it will start from x is equal to 0. You can see that this point is x is equal to 0. So I'll write 0 0 here, and the strip is not going to stop anywhere because x is tending to infinity. So this region is again an unbounded region. You can see that the left portion is bounded, but this is not bounded from the right hand side. So this is a kind of infinite region, right, extending towards infinity. So the strip is going towards x tends to infinity, right? Okay, so now okay, so this is the original picture. I'm just going to copy this picture, and now you are going to just rotate this strip, because in the original integral you actually can't evaluate the integral because you cannot integrate it with respect to y first. So what I'm going to do now, I'm going to just rotate this strip. But when I rotate this strip like this, you can see that the base of the strip is lying on the curve y is equal to x, but the head of the strip is going towards x equal to infinity or x tends to infinity. So I'm going to just extend this strip like this and like this, and it shows that the strip is not of finite height, it is going towards x tending to infinity, right? Okay, so here is the base of the strip. Now tell me on which curve the base of the strip is resting. Yes, who will tell me?
On x.
On x. You should say y equal to x or x equal to y.
Sir,
Tell
x is
me
equal to
precisely. X is equal to y. Okay, okay, x is equal to y. And the head of the strip, head
is equal to infinity.
x equal to infinity. So this is just like this picture, this one, x tends to infinity. The head of the strip is x tends to infinity. Just avoid writing x equal to infinity. And now we'll show the motion of the strip. It will be like this, parallel to the y-axis. There's a motion of the strip. The motion will be started from y is equal to 0. You can see here, right? And this is the point where the motion of the strip will be started, and it will go towards infinity. You can see that the strip will never stop its journey. The strip will be always going towards infinity. It cannot stop actually. Are you getting my point? Can you see that the motion of the strip is like endless motion. It will never stop, right? Okay, so I will now write the new integral, right? And I will mention the new limits here only. Limits of x y to infinity and limits of y 0 to infinity. Okay, fine. So the outer limits are reserved for y and the inner limits are reserved for x, right? And the function is x times e to the power minus x squared by y dx, and then we'll write dy. Now hopefully we can integrate this function with respect to x first. We can see that if I assume x squared by y equal to t, then maybe I will be able to perform integration. Let x squared upon y, or okay, x squared upon y. Okay, fine. I will take it completely as t like this. And since, please note that at this point we are going to differentiate this with respect to x, because originally you can see that the inner limits are of x limits, and you are going to perform integration with respect to x. You are going to treat y as a constant here. This is the first level of integration. When you perform inner integration with respect to the inner limits, then the other variable is taken as constant. So please take y as a constant, right? Assume that y is a constant. So just differentiate it, assuming that y is a constant. So that will be 2x by y dx. The right hand side will be dt. So that gives you the value of x dx, and that is dy dt upon 2, right? So using these substitutions, do not touch the limits of y, please. Just leave them intact like this. Okay, now you can change the limits of x as per this substitution. When you put x is equal to y here, in place of x we are going to put, in place of this x, you can see that this is x. In place of this x we are going to put this lower limit. So y square upon y will give you y, and when you put infinity here, infinity upon y is again infinity, right? Of course, infinity upon dividing by some variable y is infinity, right? Any problem in this? Any problem in this? Anyone? E to the power minus t, and dx will be replaced by x dx will be replaced by y dt upon 2, right? And now if I write y outside here, y should be written here y dy like this. Now you are going to integrate this with respect to t, and note that these limits are of t now, right? You just forget x now. Okay, now integrated with respect to t. So that gives you 1 by 2 will be taken outside, and 0 to infinity, these are limits of y, right? And when you perform integration with respect to t, that will be e to the power minus t upon minus 1. So minus 1 can be taken outside, and the limits of t are y to infinity and then dy, right? So minus half, and then you will plug the upper limit e to the power minus infinity is 0, and then e to the power minus y. Okay, and dy, you know that e to the power minus infinity is 0 as I told you earlier. Then please take this negative sign outside. So we're left with half with 0 to infinity e to the power minus y dy. Now we will integrate it once again with respect to y. That gives you e to the power minus y upon minus 1. So here you will be having minus sign now. So 0 to infinity, and then you use again that same concept. E to the power minus infinity is 0, and this is 1. The answer will be 1 by 2. Okay, so there are several steps in which I used this. Where is that? E to the power minus. Yeah, Sonu Singh, what do you want to ask? I use this thing, huh?
सर वो
Sonu
नीचे
Singh.
y
नीचे y.
हाँ सर y dy था
अच्छा वो मैंने छोड़ दिया.
हाँ
अच्छा मैंने
सर
छोड़ दिया y. ओ सॉरी y dy छोड़ दिया y. ओके, यहाँ पे भी y आएगा. y. Okay, fine. Now I have to use that integration by parts. Do you remember that rule, integration by parts?
yes sir
Okay, use that rule. So that gives you y e to the power minus y upon minus 1 minus 1 e to the power minus y over plus 1. I have used a rule of integration by parts, but it's a shortcut actually. So somewhat different from yours. Now see, you're going to put infinity here, so that gives you limit y tends to infinity y upon e to the power y. You can write it like this, minus limit, here you have already minus limit y tends to infinity 1 upon e to the power y, and then you will plug the lower limit, right? Minus, when you put 0 then it will be 0, and e to the power 0 is always 1, so the only thing left is this one. Who will tell me the answer of this thing? What is the answer of this thing? You know that this is 0. You know that this is always 0. You studied it here. This is always 0. Infinity. No, wrong answer. When you plug infinity, what form you are getting? If you put infinity here, you are getting infinity by infinity form. If you see this thing, when you put infinity, you will be getting infinity by infinity form. So you have to use that L'Hopital rule. Remember that rule? When you differentiate it, you will get 1. You differentiate it, you will get y, and then you will put it to the power infinity, that will be 0. 1 upon infinity is 0. So eventually this answer will be 0. I'm not going to write everything here. I will write 0 here only, right? And this is also 0, right? And this is plus 1. So eventually the answer is again plus 1, right? And I will put a star here like this. And I will try to explain that why this is 0, right? Should I put a, okay, let me write the explanation here only. Here, limit y tends to infinity y upon e to the power y is actually you are having infinity by infinity form, right? When you put infinity here, so using that L'Hopital rule, you are going to differentiate the numerator, that is 1, and differentiate the denominator, that is e to the power y. So you have used LH rule, L'Hopital rule, right? Okay, and then you put infinity, so 1 upon infinity is always going to be 0, right? Okay, so that's why I've written 0, and this is the explanation of why we have written 0 at that point, right? I will let star here. Shortcut formula. Okay, sure. I will write that. No problem. So I will u v dx is u, write in bracket u, and just write v1 minus u dash, it stands for differentiation, and v1 stands for integration. U dash and integrated twice v2, then sign, change sign, u double dash v3 minus u triple dash v4, then plus u 1 2 3 4th dash and v 5 and then minus then dash 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 dash. This is a shortcut formula, but this works if and only if this u is a polynomial, right? It only works when u is a polynomial form, polynomial function, right? Okay, so this formula is always helping you a shortcut, but it has its limitations. ये हमेशा काम नहीं करता, ये तभी काम करेगा जब u polynomial है। एग्जाम्पल के तौर में आपको बता दूं मैं, एग्जाम्पल बहुत जल्दी कराएगा आपसे क्वेश्चन। अगर जब मान लीजिए फंक्शन है x स्क्वायर sin x, so let me use this shortcut formula here in this question, x square sin x. See, this is your u, this is your v, right? Please pay attention, this is very important. Just write u in bracket and then write v1. v1 means integration of sin x. What is the integration of sin x? Minus cos x, yes or no? Integration of sin x is minus cos x. And please do not bring this minus outside the bracket, maintain brackets, do not take anything out of the bracket. Then use minus sign. I'm using this formula. Then differentiate this thing. What is the differentiation of x square? The differential of x square is 2x, and integrate this thing. Integration of minus cos x will be minus sin x plus, but please do not take minus sign outside the bracket, just keep them there, otherwise that will be wrong. Then sign change plus. Now differentiate this thing. Differentiation of 2x will be 2, and integrate this thing. Integration of minus sin x will be now it will be plus cos x. Then change sign. Now differentiate this thing. You can see that the differential of this thing will be 0, and it indicates that the integration is completed now. So this is a complete answer. So the answer is x square minus x square cos x. You can just write it minus x square cos x plus 2x sin x plus 2 cos x. So this is a shortcut, but this shortcut works only when u is a polynomial. It's just going to help you in some particular cases. It is not going to help you always. But luckily here u was a polynomial. It was 1 degree polynomial, so that's why I used it. Any problem in this? Please ask. Any problem?
भी आप शॉर्टकट बताएं सर, ये आइलेट का ही एक अलग रूप है सर।
अलग रूप है और बहुत अच्छा रूप है। देखिए अगर आप x स्क्वायर sin x में लगाते हैं कभी भी आइलेट को, तो आपको कम से कम आधे से ज्यादा पेज खर्च के 2 बार लगाना पड़ेगा आइलेट। x स्क्वायर है क्योंकि यहाँ पे जितनी ज्यादा पावर होती है उतनी ज्यादा आइलेट लगाना पड़ता है, लेकिन ये फॉर्मूला आपको एक लाइन में आपकी मदद कर रहा है, सिर्फ एक लाइन में आपको इसने आंसर पे पहुंचा दिया। तो ये फायदा है इस फॉर्मूले का।